the one that I had hanging on the wall for a long time. Hopefully you took a picture of it when I told everybody to. It's my poster, so it's going to be a different equation than yours, but I'm going to go through it step by step, following the Word document that I gave you and the rubric that I gave you. And what you could probably do is, as I do my part, you could pause it, do the exact same thing with yours, so that you're understanding the concepts and you're going along with me. Okay, so my equation is 2x squared plus 3x minus 27. All right, so when I look at the document that I gave, let me go to the top. Ignore the number 1 because, well, don't ignore the letters, but ignore number 1 because it says before creating your poster, you need to have all this information to me. You missed that deadline, so now you're going to have to do it all and make sure it's correct before you put it on the poster. The first question, 1A, says write your equation in standard form, vertex, or in standard vertex and intercept form. All right, so when I go back to my equation, this is standard form. So standard form's already done for you. Okay, that's standard form. So I need to figure out how to write it in vertex form and how to write it in intercept form. And to write it in vertex form, we complete the square. Okay, so I'm going to go through the process of how to complete the square with my problem. And then if you want to pause it and go through the same process on how to complete the square with yours, that might be the easiest for you to do as we go through this. So I'm going to take 2x squared plus 3x minus 27, set that equal to 0. I'm going to add 27 to both sides. So I want the constant on one side and every term with a variable on the other. I'm going to leave a space. I don't need to put the plus there. And this is what I have. So to put it in vertex form, we complete the square. What I'm going to do is factor a 2 out of the left. When I do that, this becomes 3 halves. You can always check it by multiplying 2 times 3 halves and seeing if you get 3, which is what we started with, and we do. Okay, once I've factored the 2 out, what I'm going to do here is I'm going to add a number that when squared is going to go up here. Okay, so 3 halves. In order to get that constant that I add inside the parentheses, I'm going to take half of 3 halves, which is 3/4. And if you don't believe me, 3 halves times 1/2 is 3/4. Okay, so anytime I take half or a quarter or a third of a fraction, I'm just going to multiply the denominators. So half is 3/4, and then I'm going to square this. 9/16. Okay? So that's what I'm adding inside the parentheses. The thing is, I factored a 2 out. Okay? And by factoring a 2 out, when I figure out, I can't just add 9/16 to the left. I've got to add something to the right so that the equation stays equal. So when I multiply 2 times 9/16, that's 9/8. So what I really added to the left was 9/8, not 9/16, because I multiply everything in the parentheses by 2. So now I can say this equation, actually like this. Okay, if I added 9/8 to the left, I have to add 9/8 to the right. Okay, so I've got it this far. First, I'm going to go ahead and figure out what 27 plus 9/8 is. So I've got to get a common denominator. Okay, which is 225/8. Okay, so my right side's 225/8. My left side, I've got to go ahead and factor. This is why we complete the square, so that we can factor this into a squared binomial. Binomial means 2 terms, and I'm going to take those 2 terms and I'm going to square it. So to get it into factored form, what I'm looking for is what I had to square to get this term. Okay, so what I squared was 3/4. And I can check this. X plus 3/4 times itself, which is what x plus 3/4 squared is. Okay, x times x is x squared. X times 3/4 is 3/4 x. X times 3/4 is 3/4 x. and plus 9/16. So 3/4 plus 3/4 is 3/2. And in fact, the way I factored it matches what I started with. X squared plus 3/2 x plus 9/16. Okay, so now I've got it in this form. I've completed the square, but I want to get it into vertex form, which is a y equals. So to get this in vertex form, I've got to move this over by subtracting it. Okay, so that's the second form that we had to get, vertex form. Okay? So now the third form, if I look at the document, it says standard. I did that. That was given to me. Vertex, I just did by completing the square. Intercept form. So intercept form, if this is my original equation in standard form, intercept form, I have to factor this. Okay? We learned a factoring method called the bottoms-up method. The bottoms-up method says you take the leading coefficient, multiply it by the constant. Rewrite this with that product at the end. Okay? Now we're looking for factors of -54 that add up to 3. One has to be positive, one has to be negative. The sum is positive. Okay? Well, if I take 9 and 6, make 9 positive and 6 negative, multiply together equals -54, added together equals 3. So x plus 9 times x minus 6 equals, this is just y. Now, when I do the bottoms-up method, I had to multiply the constant by 2. So I've got to remember to divide the factors by 2. Then I simplify if I can. If I can't, like I can't with this one, I bring the bottom up. And here I can simplify. And now it is factored. Okay, this is factored form, which is intercept form. And the reason it's intercept form is once it's factored, I can tell you, looking at it, what the x-intercepts are. This is -9/2, this is +3. We'll talk about that a little bit later when we have to do the roots. Okay? But getting it into intercept form will let me see the intercepts or the roots or the zeros right away just looking at it. Okay? Getting it into vertex form, I can scroll down, lets me see the vertex right away, which is why it's called vertex form. So I can see what the vertex is, and we'll talk about that in a minute when I'm asked to find the vertex. In standard form, I have to use a couple of equations, and I can find the vertex in standard form. But in standard form, the thing I can see right away is the y-intercept, because the y-intercept is always the constant. Okay, so we've done letter A. Letter A says write your equation in standard, vertex, and intercept form. We did that. Now, letter B says, does the parabola open up or down? How can this be determined from the equation? Well, remember, all quadratics, which are x squared plus, let's call it ax squared plus bx plus c, all quadratics are parabolas. They're going to be parabolas that open up, or they're going to be parabolas that open down. Okay, but they're always going to be graphed as parabolas. Now, the way I can tell whether it opens up or down is the leading coefficient. The leading coefficient is the coefficient in front of the term with the highest exponent. In this case, the exponent's 2, so the leading coefficient. I'm looking at the sign of this leading coefficient. If it's positive, it opens up. If it's negative, it opens down. Well, if I look at my problem, my leading coefficient's +2. So for letter B, I know that the parabola opens up because the leading coefficient is positive. All right, letter C. Letter C says, what's the equation for your axis of symmetry? Axis of symmetry in a parabola is the line that splits that parabola in two equal halves. So a point over here, if I mirror it over the axis of symmetry, will be the same distance from this line. The axis of symmetry is this line. And if you notice this is a vertical line, and all equations of vertical lines are x equals something. So if I can find the x-coordinate of the vertex, the axis of symmetry will go right through that. Well, to find the x-coordinate of the vertex is the equation negative b over 2a, where this is a, which is just 1, this is b, this is c. I don't use c to find the vertex. So the vertex is negative b over 2a. So that's negative 3 over, actually there is a 2 there, sorry, over 4. So my axis of symmetry is the line x equals negative 3/4. Of okay, next problem. It says, what are the coordinates of the vertex? All right, well, I just found the x-coordinate, but I need to find the y-coordinate of the vertex. I found the x-coordinate here, but I've got to find how far down it is or above the x-axis. I need to find the y-coordinate. To do that, I'm just going to take what I found and plug it in. 2 times negative 3/4 squared plus 3 times negative 3/4 minus 27. Now I'm going to simplify that. Negative 3/4 squared is 9/16. And this will be a minus when I multiply. 9/4 minus 27. So 9/16 times 2 is 9/8. 9/8 minus, I'm going to go ahead and just convert this to eighths along the way, so I have common denominator. And I have what? Maybe 2, let me just make sure I did this right. 27 times 8. Okay, 243. Does that seem right? No, because this is negative, this is negative. So it's really, I'm just subtracting 8 from 216, which is 208. I'm subtracting 9. Help if your math teacher could do math. 207. Yes. 9/8 minus, if I multiply this by 2, get 18/8, and 27 times 8 is 216/8. Okay, so negative 207/8. I'm trying to make sure that I've written my problem down right. 2 times x squared plus 3 times x is minus 9/4 minus 27, negative 207/8. Okay. And I'm thinking, I ended up getting 225. I'm just going to do this again real quick. 9, and it's because, no, 9 over 16 times 2 is 9 over 8. $225 minus 16 is 9. So I am, that's right. It's negative 225 over 8, because this is negative 9 plus negative 16. Okay, having a little brain issue on this Friday afternoon. Okay, negative 225/8 is my y-coordinate. Okay, so this is negative 3/4, negative 225/8. That's my vertex. Okay, which is what I needed to find for letter D. Okay, let's go on to letter E. What's the maximum minimum value of the parabola and how is it determined? Okay, so if I go back into my, maybe, and I look at those two graphs that I showed you. Okay, notice that if this graph, this parabola opens up, the vertex is a minimum. That's the lowest value of y that this graph will ever see. If the vertex opens down, this is a maximum. That's the highest value of y. Well, we've already identified that it opens up, so we know the y-coordinate of the vertex is going to be my minimum value of this function. The y-coordinate of my vertex is negative 225, so it's a minimum, and it happens at y equals negative 225. The reason it's a minimum is because it opens up. All right, on to the next one. What is the max? Oh, we did that. What is the y-intercept? Okay, standard form is the easiest way to see the y-intercept. The y-intercept happens when x is 0, because it's on the y-axis, and on the y-axis x is 0. So the y-intercept in standard form is always your constant. So my y-intercept is negative 27. And I should really make it a point. So it's when x is 0, y is negative 27. All right, next is what are the roots? Okay, we're supposed to solve by factoring, we're still supposed to solve using the quadratic formula, and we're supposed to solve completing the square. So let's go back and look, get this up. My standard form is this. My intercept form was 2x plus 9, x minus 3. And my vertex form was 2 times x plus 3 halves squared minus 225 sixteenths, I believe. I'm going to go back up and just check that. 2 times x plus 3/4 squared minus 225 eighths. So I got to fix that. Memory's not quite what I thought. All right, so this is standard form. This is intercept form. This is vertex form. Okay? The thing is, all three of these are the exact same parabola. If you type this in the graphing calculator, you type this in the graphing calculator, or you type this in the graphing calculator, your parabola will be identical. There's just three different forms. Just like we can write equations of lines differently. We can do y equals mx plus b. We can do ax plus by equals c. There's lots of different ways to make a line. These are the three ways to make a parabola. Each of these tells us something different. This one will tell us the y-intercept. This one will tell us the x-intercepts, or the zeros. This one will tell us the vertex. Okay, so what this letter on the Word document asks us to do is find the roots, or the intercepts. And they want us to do it by factoring, which we've done, by completing the square, which we've done, and using the quadratic formula, which we will do. Okay, so let's start with quadratic formula, because that's the first one, standard. So the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. Okay. This is A, this is B, this is C. Negative 3 plus or minus the square root of 9, which is what 3 squared is, minus 4A times C. All over 2 times 2, which is 4. So in the calculator, I take 9, it's going to be plus, because I have a negative 4 times negative 27, plus 8 times 27, which is 225. So it's negative 3 plus or minus the square root of 225 all over 4. Well, this equals negative 3 plus or minus 15 all over 4. Simplified, negative 3 plus 15 is 12 over 4. Negative 3 minus 15 is negative 18 over 4. Simplified there, I have zeros of 3 and negative 9 halves. So these are my roots, or zeros, or intercepts. All mean the same thing. They are the x-intercepts, but we call them roots, zeros, or intercepts. If someone asks you what the root is, all you're doing is finding the x-intercept. by setting your equation equal to 0. All right, so I just found the roots using the quadratic formula. Now I'm going to find the roots from the intercept form. So all I do, I need to set this equal to 0. I'm going to set 2x plus 9 equal to 0, and I'm going to set x minus 3 equal to 0 and solve. Subtract 9, divide by 2, x is equal to negative 9 halves. Add 3, x equals 3. So note, the zeros from standard form and the zeros from the intercept form are the same zeros. Because it's the same parabola, it's going to have the same roots. We're just finding them in 3 different ways. Okay, now to find the roots from completing the square or the vertex form. I'm going to set 2 times x plus 3 halves squared. It's 3 halves, I think it's 3/4 actually. Sorry about that. Minus 225/8 equal to 0. So don't distribute this back. We factored it for a reason. All we're going to do is add 225/8 to both sides. And on the left, I'll end up with 2 times x plus 3/4 squared equals 225/8. Divide by 2. That becomes 225/16. Take the square root of both sides. 15/4. Subtract 3/4. And this is plus or minus. Don't forget that. So I have negative 3 plus 15 is 12/4. I have negative 3 minus 15 is negative 18/4. So I get the exact same. My roots are 3 and negative 9 halves. I got the exact same roots all 3 ways. So that's a good way to check your math. You should get the exact same roots all 3 ways. Okay, let's figure out what's next. I did this. I solved by factoring, I solved by using the quadratic formula, and I solved by completing the square. So the question now says, how do you find the other points on the parabola? All right. I want you to find 3 points on your parabola. Let's see if I can get my grid to show up. All right. I'm going to go by 2's. My vertex I found was negative 3/4, negative 225/8. 225 divided by 8 is 28 and an eighth, basically. So I'm going to go negative 3/4, and I'm going to count by 2's. So it's going to be closer to here. And I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, what did I say, 28? Yeah, let me try again. 2, 4, 6, 8, 12, 14, 16, 18, 20, 22, 24, 26, 28, and a little more. So there's my vertex. It's going to be a sketch here. So this vertex is negative 3/4 and negative 225/8. That's the vertex. Okay, I also found my y-intercept to be negative 27. So if I'm going by 2's, that means negative 27 is going to be there. Remember what I told you, the x-coordinate of the vertex is your axis of symmetry. So I could just kind of sketch that in. That line is x equals negative 3/4. So the axis of symmetry says every point on the right side is going to be equidistant to the axis of symmetry at the same level of y value. So this point, negative 27, if I go to the other side of the axis of symmetry, that's going to be 3/4 away from this, which is 1.5. So it's a little closer. I've got to do it at, that's really on 2, but you get the idea. So this point is negative 1.5, negative 27. This point is 0, negative 27. I found the y-intercept. I need to find 3 more points. I just found 1. Okay, so I need to find 2 more. So what I'm going to do is pick any number and put it into my original equation and solve for y. So let's just pick 2. 2 times 2 squared plus 3 times 2 minus 27. There's no right number to pick. You get to pick whatever number you want. Pick it. Okay, put it in. 4 times 2 is 8, plus 6 minus 27. 14 minus 27 is negative 13. Okay, so the coordinate is 2, which is here, negative 13. 2, 4, 6, 8, 10, 12 and a half. So there's this point, 2, negative 13. Well, this is 2 3/4 units away from the axis of symmetry. So I need to go 2 3/4 the other side. So it's going to be a total of 5 1/2 away. So if I go, hold on a second. I am, what did I say? 2 3/4 units away plus 3/4 is 3 1/2. So it's going to be at negative 3 1/2. There's negative 2, 3, come down. There's my third point at negative 3 1/2, negative 13. Okay, so I have now these points, and what's interesting, I already found my zeros. My zeros were 9/2. I think it was negative 9/2. Let me check. Negative 9/2 and 3. Negative 9/2 is negative 4 1/2, 2, 4 1/2. So there's 1. And 3, 2, 3. There's the other. And now I've got enough to just do a sketch. And I can label these as negative 9/2, 0, and 3, 0. Okay, so I found the vertex. I found the y-intercept. I mirrored that over the axis of symmetry. I found another point. I could have chosen 1, 2, 3, whatever number you want. I found that point. I mirrored it over the axis of symmetry. I knew the zeros because I solved for those in the last step, plotted those, and now I've got enough to just get a general sketch of my parabola. All right, let's see what's next. Graph the parabola. So I say to graph it on GeoGebra. GeoGebra is nice. It's a free app that you can use. If you don't want to use it and you want to just just graph it yourself, then do that, graph it yourself, but make sure your axes are labeled, that I know each of the units. So on this one, I should have said this is 2, 4, and so on, to know I went by 2s. If you don't go by 2s, that's fine, but just make sure you label this correctly and that all your points are labeled. I know that this is the vertex. I can call this the y-intercept. I can call this the x-intercept or roots, and this the x-intercept. Okay, this is much messier than yours should look, but that's what I'm looking for. I want to see the axis of symmetry labeled. I want to see every point that you just found, the vertex, the y-intercept, the 3 additional points, and your x-intercepts or your roots. I want those on your graph. Okay, and that's what I'm looking for. All right, so let's look at, those were all the steps to actually go through before you actually make your poster. So now let's get to making your poster. If I look at the rubric, I need to go to the top of it. Okay, you need to have your direction of opening. Is it up or down? And why? That's worth a point. You need to have your axis of symmetry written somewhere on your board. My axis of symmetry is x equals negative 3/4 was mine. You need to have your vertex written somewhere on your board. My vertex is negative 3/4 comma negative 225/8. You need to have your maximum minimum value and how you found it on your board. My minimum value for mine was negative 225/8. You need to have your y-intercept somewhere written. My y-intercept is 0 comma negative 27. You need to have found the roots by factoring, by completing the square and using the quadratic formula. You need to have found 3 other points, and there needs to be a graph that's labeled. I'm not going to dock you 3 points if it's not in GeoGebra. If you can do it just on a graph paper, that's fine. This graph has a scale, so if you don't use 1 for your units, you use 2 like I did. Make sure you write the scale and that you label everything. I also want a real-life example. There's several people found near Kimball that I can think of. I'm okay if you want to use anything that you can find off the internet. Okay, real-life example. It doesn't have to be in Kimball. You can either print a photo from the internet or just sketch it. Tell me where it is. Okay, so in order for the poster, this is what's required. The problem needs to be written at the top. The statement, the parabola for this equation opens blank because blank. That has to be on the poster somewhere. The process used to identify the vertex is described. including any formulas used. And this is in standard form, okay? So when it's in standard form, to find the vertex, you use the equation x equals negative b over 2a, and you plug that in to find y, and that's the process that you've got to write on your poster, how you did that. How you identified the y-intercept when in standard form. Well, to identify the y-intercept, you set x equal to 0, so the y-intercept for me was 0, negative 27. It's equal to the constant when it's in standard form. Okay, in the vertex form section, the process used to identify the vertex is described. So let's go back. We haven't talked about that yet. Okay, this is my vertex form. In vertex form, this is the, actually there should be an A there. This is the general form of a parabola in vertex form. Okay, I don't have any numbers in it. So when I compare this to this form, I can tell that if my x-coordinate of my vertex is positive, there's going to be a minus between them. If my x-coordinate of the vertex is negative, there's going to be a plus between them. So it should be negative 3/4, and then the sign here is whatever is written. So it's opposite of what you think for the x-coordinate of the vertex. Here it looks like it should be positive 3/4, but because the general form has a negative, it makes this positive, the opposite sign, negative 3/4. The y-coordinate of the vertex is always just how it's written. Okay, so in vertex form, that's how I identify the vertex, and that's what this is asking. The process used to identify the vertex is described. So you're going to say the general form is y equals a times x minus h squared plus k. My h is 3/4, so it must be negative. It's going to be negative 3/4, comma, negative 225/8. In vertex form, the process used to identify the axis of symmetry is explained. Well, this is really easy in vertex form because remember the axis of symmetry is just the x-coordinate of the vertex. Okay, so that's the axis of symmetry. And you can just explain that saying it's just the x-coordinate of the vertex, and then tell me what it is using the vertex form section. Can't talk and write at the same time. Okay. So on your poster, you're going to have a standard form section. You're going to have this described. You're going to have a vertex form section, and in that vertex form section will be the place that you're going to describe how you complete the square. Okay. In the intercept form section, you're going to tell me how to find the x-intercepts, and you're going to tell me how to find the vertex. Okay. The x-intercepts. X minus 3. Yes. Okay, so when you have it in intercept form, what's given to you are the roots or the zeros. We've already talked about that. The roots are negative 9/2 and 3. To find the vertex from intercept form, the vertex happens at the midpoint of these two, right? Because the axis of symmetry has, both of those points are on the x-axis. The axis of symmetry is going to split those points in half. So we just need to find the midpoint between these two. And to find the midpoint, we add the two together, whatever their signs are, carry through, divided by 2. So let's get a common denominator. 6 minus 9 over 2 divided by 2. Remember, if I divide by a fraction, it's the same as multiplying by the reciprocal. 6 minus 9 is negative 3. 2 times 2 is 4. There is the x-coordinate of my vertex. To find the y-coordinate, you plug that x-coordinate in here and here. So I have 2 times negative 3/4 plus 9 times negative 3/4 minus 3. Well, this is negative 6/4, which is 3/2 plus 9. Well, that's 18/2 times negative 3/4 minus 3, or 12/4. So I take negative 3/4 minus 12/4. Okay, so I have here 15/2 times negative 15/16. getting anywhere here? So this becomes negative 225. I got 32. Should be 8. So I did something wrong. 3 halves, well, because 2 times 4, this is 4. Mrs. Reader, do fractions correctly. Negative 3/4 minus 12/4 is negative 15/4. 4 times 2 is 8. So you can see how you're doing your math. You can check, because we found the vertex a different way. We used the negative b over 2a method. So when I got 32 here, I knew I had done something wrong. Okay? Because it should be the exact same vertex that we had before. It's the same exact parabola. So I was able to go back and catch my math error. So ask yourself, does my answer make sense? Okay? The vertex using the intercept form is negative 3/4, negative 225, 8. Okay? And that's how I do it using vertex form, which is what this is, our intercept form. The process used to identify the vertex is described. That's what I just did. And the formula that you might use is the midpoint formula. Okay, now looking back. So the axis of symmetry, there should be a statement that says the axis of symmetry is x equals whatever. It needs to be a line, x equals whatever your number is. The statement the vertex is located at needs to be included. You get a point for that. A description of how to determine if the function has a maximum or minimum is included. Remember, if the function opens up, it has a minimum. If the function opens down, it has a maximum. The statement the y-intercept for this equation is blank. Mine would be 0, negative 27. X-intercepts are found using, let's see, the x-intercept section. You found it by factoring, you get a point. If you found it using the quadratic formula, you get a point. And if you found it by completing the square, you get a point, as long as you show me how you did that on your poster. The statement, the roots of this quadratic equation are, well, those are your x-intercepts. You just need to write the statement. Mine would be negative 9/2, 0, 3, 0. The other point section, if you find the other point by symmetry, you get a point. If you find 2 other points through substitution, which is what we did, you get a point. If the graph is drawn on GeoGebra and included on the poster board, you get a point. If you do it by hand, I'll give you a point for that. If your name is on the back of the poster, you get a point. If it's neat and legible with each section clearly labeled, you get a point. So there's a total of 54 points. Okay, hopefully that helped. Again, go through the video and stop it when you need to, and try your problem doing the exact same methods that I'm doing. Once you have all of your information, you'll be able to put it on your poster. And I can take if you didn't take a picture of it, I'll take a quick picture of my poster so you can see it, and you can use the same format. Hopefully this was helpful.